So let's talk about the derivatives of the vector functions. So in order to define them, we need the limits, right? So do you remember how we define the derivatives of the functions of the single variables? So if we're given a function of a single variable, f of x, its derivative by the definition is the limit of f of x plus h minus f of x divided to the h, where h goes to the 0, right? We are going to define the derivative of the vector functions in the same manner, okay? So if we're given a vector function r of t, its derivative r prime of t, or we denote this as dr dt, this is the vector, it's going to be equal to the limit of r of t plus h minus r of t divided to the h, where h goes to the 0. Okay? So let us write down the theorem. Theorem tells me that let the vector function is given in the form f of t, h of t, and g of t. Okay? Then the derivative of the r with respect to the t, it's going to be a vector with the three components. The first component is going to be the derivative of the f. The second component is going to be derivative of the h. And the third component is going to be derivative of the g. So let's quickly prove this. So let's start from the definition. So the limit of, or r prime of t, is equal to the limit of r of t plus h minus r of t, divided to the h, right? Do you remember what was the r of t plus h? This is f of t plus h of t plus h, and g of t plus h, right? So r is the vector function. It means that it takes one input. In this case, it takes the input t plus h, and it gives you back a vector, which has the three components. This one, and this one, right? So minus r, when it takes as the input simply t. It is going to be f of t, h of t, and g of t. Okay? Divided to the h. So now what we need to do is we just need to do the vector operations, right? So when you subtract the two vectors, you need to subtract them component-wise. And when you divide a vector to some constant, you need to divide every single component of the vector to this constant, right? This is kind of a multiplication of a vector to some constant, right? So where h goes to the 0, it is going to be. So we need to subtract the vectors component-wise, and we need to divide every single component of the vector to the h. This is going to be f of t plus h minus f of t. This is going to be the first component. The second component, h, this h is different from this h, okay? This is the constant, sorry. H of t plus h minus h of t divided to the h, and g of t plus h minus g of t divided to the h. So do you remember previously we said that the limit of the vector is equal when we find the limit of every single component separately, right? This is going to be the limit of the first component, the limit of the second component, and the limit of the third component, where the f, h, and g are functions of a single variable, okay? For the functions of the single variables, when we find a limit of this kind of limit, it means just the derivative of this function, right? This is going to be the derivative of the f with respect to the t, derivative of the h with respect to the t, and derivative of the g with respect to the t, okay? So let's do a small example. So r of t is given as 1 plus t cubed multiplied to the I, t e in the power of minus t multiplied to the g, plus sine of t multiplied to the k. So what you need to do is you need to find the derivative of this function. Okay? So there is nothing difficult with finding the derivative. This is just a different notation of the vectors, right? So we can write down these three components of the vectors using the vectors I, j, and k. Here, this coefficient before the I means the first component of the vector, coefficient before the j means the second component of the vector, and coefficient from the k means the third component of the vector, right? And when you need to find the derivative of the t, of the r, you just need to find the derivatives of the functions before each of the components, right? Separately. So what is the derivative of the 1 plus 3t cubed? It's going to be 3t squared, right? Multiplied to the I. Plus, when you multiply, when you take the derivative from this, you need to use the multiplication rule. So you need to take the derivative from the t first and multiply this as the e in the power of minus t, right? And multiply the t to the derivative of the e in the power of minus t, which is going to be minus e in the power of minus t, right? And this is multiplied as a j. And when you take the derivative of the sine, it's going to be simply cosine of t, and this is multiplied as a k. So you can write down the derivative of this vector function using the different notation. It is going to be 3t squared, e in the power of minus t in the power of minus t, and cosine of t.